In-class activity 19D, adding rational functions. 1. For an electrical circuit, Ohm's law states that I equals V over R, where I is the current measured in amps, V is the voltage measured in volts, and R the resistance measured in ohms. Part A, if the resistance does not change, but the voltage increases, does the current increase or decrease? Well, if the voltage increases, that means for part A, the current also increases. Let's write current increases. Part B, if the voltage does not change, but the resistance increases, does the current increase or decrease? Well, if the resistance increases, the current decreases. All right. Objectives for the activity. You will understand how to find a common denominator when adding two rational functions. You will be able to add rational functions to form a new rational function. 2. An electrical circuit is built with two components in parallel. According to Ohm's law, the total current I is the sum of the currents in each component. That is, if R1 and R2 are the resistances in the two components, and V is the voltage in each component, then I equals V times 1 over R1 plus 1 over R2. For a given circuit, suppose that the voltage is constant at 12 volts, but that the resistance increases over time. We will assume that R1 of t equals t squared plus 1 and R2 of t equals t plus 1, where t represents time measured in months. Part A, explain how R1 and R2 change over time. Well, both will increase over time. And we can say R2 increases linearly. And R1 increases quadratically. Let's go on to the next part. There we go, part B. Use Ohm's law to write a formula for a function where I of t represents the total current at time t. Well, we could write I of t is equal to 12, and then we have in parentheses, we have 1 over t squared plus 1 over t plus 1, and we'll close the parenthesis. Part C, write the formula for I of t as a single fraction. Well, we have I of t, and I'm just copying down the same thing I just wrote, over t squared plus 1 over t plus 1. And inside the parentheses, we have two fractions, and we need a common denominator, and we can use t squared plus 1 times t plus 1 for the common denominator. So let's do that. We have 1. I'm just writing the first fraction here. And then to make this denominator the common denominator, looks like we'll need a t plus 1. So we'll need a t plus 1 in the numerator as well. And then we'll do the same thing here. For the second fraction, we have a t plus 1 in the denominator. We need the t squared plus 1 piece, t squared plus 1. And we can clean this up a bit. So if we include the 12 in the numerator, and then write this as a single fraction, collect like terms and so forth, inside the parentheses, we'd get a t squared plus t plus 2. And then the common denominator wouldn't change. It'd be t squared plus 1 times t plus 1. Part D, as t increases from 0 to 10 months, how does the total current change? Well, let's just plug these numbers in. If we plugged in a 0 everywhere, we saw a t. We get 0 squared plus 0, 2. This one ends up being 2 times 12 is 24 over 1, which is, we'll just write as 24. So that's 24 amps. If we do the same thing again, but we're going to put in a 10 this time. We're going to get a 12 times 10 squared plus 10 plus 2 over 10 squared plus 1, 10 plus 1. So this would end up being, let's see, 12, let's say 12, and let's say 112 over 101 times 11. And plugging this into the calculator, we would get a number a little bit more than it'd be about 1.21 amps. So the total current would drop from 24 to just about 1.2 amps during that period. Part E, at what time is the total current equal to 12 amps? Okay, so at what time is the total current equal to 12? So why don't we put a 12 and set that equal to our 12 t squared plus t plus 2 over t squared plus 1, t plus 1. If we cross multiplied, let's work over here for right now, we get 12 times t squared plus 1 times t plus 1. That's a 1 there. And then what would we have on the other side of the equation? It'd be the 12 t squared plus t plus 2. At this point, if we got rid of the 12s and simplified this equation, we would end up seeing that t cubed, oh, that's a minus sign, and we get t cubed minus 1 is equal to 0, and just by inspection here, observation, we can see that t equals 1. So this answer would be 1 month. Part 4, let me just scroll up here. Part 4 says, a commercial airplane flying west to east across the United States will generally fly faster because of the influence of the jet stream. Jet streams are fast-flowing air currents in the atmosphere at a height of over 30,000 feet. Assume for this example that the jet stream flows at 100 miles per hour. Part A, let x represent the base speed of the plane in miles per hour, ignoring the jet stream. Now, suppose that the plane travels 2,000 miles in the first part of its route with the jet stream, thereby increasing its overall speed. How long does it take the plane to travel this distance? Well, since the plane is moving with the jet stream, its speed is going to be speed of plane is going to be the x plus 100 miles per hour. So it's going to take the plane, let's see, 2,000 over x plus 100 hours to travel. Oops. That's right, 2,000 over x plus 100 hours to travel this distance. Okay, let's go to part B. The second part of the plane's route has the plane traveling at speed x without the jet stream for a distance of 400 miles per hour. How long does it take the plane to travel this distance? So it's going to take the plane 400 over x hours to travel this distance. So part C, it says determine a formula for the function that gives the total length of time for the plane to travel this route in terms of x. Okay, so why don't we call this t of x, and that's going to be the first expression that we wrote, 2,000 over x plus 100, plus the second expression that we wrote, 400 over x. And if we simplify this, we would end up with we'd end up with 2,400x plus 40,000 for the numerator, and then x times x plus 100 for the denominator. Part D, what should the plane's base speed x be if it needs to travel the entire route in 5 hours. Okay, so let's do this. All right, t of x is equal to 2400x plus 40,000 over x times x plus 100, and set that equal to 5. If we multiply or cross multiply, we would end up with 5x times x plus 100 equals 2400x plus 40,000, which would be 5x squared plus 500x equals 2400x plus 40,000. And then I'm just going to set this equal to 0. So 5x squared minus, get rid of the plus sign, so we'll have minus 1900x minus 40,000 equals 0. And I have this set up in the calculator here. So if I go to the Y1 screen and we graph that and we look for the root, we can see x is going to be 400. So let's go back to where we were, and 400. So the plane must have a base speed of 400 miles per hour. All right, that's the end of this video. Thank you.